How to build a field-erected storage tank for use in oil and gas industry. In the oil and gas industry, storage tanks are used to store gas liquids, produce water and oil. The gas and liquids stored in tanks are subject for further treatment and gravity separation. For several oil and gas operators, the greater volume on tank storage can lead to potential profits by variably increasing production. Retention time for separation is increased. Combination of variably sized storage tank can make a storage depot, either located above the ground or underground. The construction of field-erected steel tanks for storage purposes like oil, produce water or brine and some other liquids are governed by API 650. The API 650 outlines the minimum requirements for material, design, fabrication, erection and testing for steel storage tanks. Materials for tank construction can be made of a carbon steel or a stainless steel with various sizes, thickness and yield capacities for varying internal pressures. In this video, we will limit the scope on a carbon steel tank, field erected on the project location. This video also applies to a tank whose entire bottom is uniformly supported by the ground or foundation and specific to a fixed roof type. The primary material used to manufacture the tank is a carbon steel, with 3/16 of an inch plate thickness and with an ANSI flange rating of 150. The steel tank will be placed on a level floor surface, face down at an angle of 1 to 8, with a bottom plate. When planning for a storage tank, it begins on determining the size based on the volume of the liquid produced in the production field. This is a collaboration effort performed by engineers, project managers, field operators and designers. When the volume and corresponding tank size is agreed, the process of selecting materials for the tank shell, the requirement on roofs, seismic design considerations, tank leak detection and subgrade protection, allowable external loads on tank shell opening will follow. The thickness of the shell will be calculated based on a hoop stress, height of the tank and the yield strength of the metal plate. A design engineering firm can calculate thickness requirement of any tank at any size with given known data like temperature, operating pressure, volume and specific gravity of the liquid stored. A software like Intergraph Tank can also be used. Intergraph Tank can perform calculations in accordance with the latest API standards. The tank field layout can be performed by the contractor following the plot plans prepared by the engineering firm. Staking and layout is essential to make sure the tank is aligned and square with the existing facilities. The foundation of a tank plays a vital role in its stability and longevity. Conducting a soil testing or soil density tests are necessary to ensure that the ground can withstand the weight of a fully loaded tank. A geotechnical engineering firm will be helpful in performing soil testing on the tank site location. Results of the soil density test will identify the bearing capacity of the soil, which determines the quantity of filling materials and the compaction requirements. Depending on the soil analysis, the existing ground cover may have to be replaced with top-quality filling materials such as fine gravel, coarse sand, or crushed rock. The filling materials provides a solid base to support the dead weight of the tank and its contents, and ensure that it remains stable and secure in any situation. The purpose of the tank ring is to prevent wash out of the coarse aggregates that are compacted and uniformly placed to support the tank bottom. Stainless metal sheets or galvanized sheets are commonly used for the tank rings as it is resistant to corrosion. The tank bottom floor will be constructed by binding the metal steel plates together. Welding procedure will be selected, reviewed and approved. Once a welding procedure is selected, several arc welding techniques based on the approved welding procedures will be followed. Metal sheets for tank bottom can be butt welded with either square or V grooves. The welder must continuously monitor and check the welded plates for achieve full penetration weld. NDT testing will be performed once welding on tank bottom are complete. The steel plates used on the tank bottoms could be thicker than the tank wall steel plates due to the hydrostatic pressure of liquid in the tank. There are several precautionary measures mandated by OSHA while conducting welding in the oil field. Cutting, brazing and any type of work that can create a spark or arc will requires a hot work permit. A trained fire watch person equipped with fire extinguisher is required to be present during the hot work or field welding operation. Heavy lifting equipment like crane or a forklift with boom extender is necessary when constructing a tank. This equipment can easily move and lift metal plates easily, which speeds up the progress of work. Critical lifting plan may be required depending on the equipment lifting capacity. After the tank bottom has been fabricated, the contractor may start fabricating the cone roof for the tank. Depending on the proposed slope of the cone roof, diameter of the metal sheets could be larger compared to the tank bottom. Steel C-channels rafters will be located and welded outside surface. One seam of the tank roof will be left open and will be fully welded once it has been lifted to the tank for final assembly. After welding and fabrication of the cone roof, the whole assembly can be set aside on a location closer to the tank bottom. Lift lugs are welded on the sheets for lifting purposes. Contractor shall use the right shackles during lifts. After the tank rings made of a galvanized steel plate with a thickness of 3/16 of an inch and 5 inches width are installed on the perimeter, and tank bottom floor are welded and set, the installation of first course begins. Tank is constructed and welded based on a sheet-by-sheet method. Steel plates are erected with the help of forklift equipment and will be temporarily spot welded to prevent tank shell movement. Welders will continuously check the center measurements and vertical alignment. Rolled metal sheets will align to perimeter wall of the tank. Welders can use shims to correct elevation and spacing of the tank during the welding process. Steel plates will be braced temporarily to hold it in vertical position using angular steel bars. Before any installation on the second or further courses of tank shells starts, the temporary side walkways will be constructed for the welders. Installing scaffolds is another way to provide temporary walkways for welders while working on the second and third courses of the tank rings. Scaffolds are regulated by OSHA under the 29 Code of Federal Standards 1910.28. Working on this type of structure is very dangerous due to slips, trips and falls that could result to a severe injury or even death. Before starting any work in platform or scaffolds, it is a good practice to check if the structure is secured with no defects. Fall protection systems is required to safely secure workers. When working on scaffolds, workers should also wear hard hats with ANSI-approved or OSHA-approved headgear and protective clothing. Hanging of the shell plates on the second to fourth course are made by the use of extendable forklift or a boom crane. The metal sheet lifting clamp connected to the hoist with the use of a high tensile cable will become useful at the point. The tank construction project is a very challenging undertaking for the installers. Only pre-qualified contractors are allowed to build tanks. Workers have to be extra careful not to drop the heavy metal sheets accidentally on themselves or each other. They will be in danger of being seriously injured, or even killed if they are hit by falling metal sheets. On the fourth course of the tank shell installation, a rolled angular ring is installed and welded fully to the tank shell perimeter wall. With the use of the crane equipment, the whole prefabricated roof assembly will be lifted and installed in the tank. The cone roof will be mounted and spot welded temporarily while finalizing the tank slope. After the target slope has been set, the last seam in the cone roof will be fully welded. Once the installation of the fixed tank roof is complete, the tank itself becomes a confined space. Permit entry in the tank will be required due to carbonic fumes from the welding machine. This lowers oxygen levels and may become a danger zone for all workers entering the tank due to poor ventilation. Regular monitoring of air quality should be done by a safety or qualified person on site. Tank appurtenances will include selection of bottom connections, sumps, shell manways, drains and connections flanges for tank levels instruments. Also included are the top tank flanges, hatch locations, inlet and outlet flanges for incoming and outgoing flow streams. Bottom connections, sumps, manways, nozzles and couplings. Tank appurtenances also includes permanent shell attachments like wind girders, stiffening rings, stairs, platforms, conduit supports, pipe supports, mixer supports, grounding clips, anchors. At a minimum, tank builders should be supplied with a list of desired appurtenances and its placement in the scope of work during project bidding. In addition to the appurtenances list, a tank nozzle orientation diagrams may be provided to give the tank builder the type, quantity, size, placement, elevation, and projection of each appurtenance. Tank hydrotesting is a process of testing the structural integrity of the tank to ensure that there is no leaky connections on the welded seams. It involves subjecting the containment structure to a pressure test in order to evaluate its strength, durability, and leak-proof qualities. This is generally done by filling the tank with water to prescribed levels and then increasing the pressure gradually until it reaches a predetermined value. Tank hydrotesting will require a discharge permit and testing for the discharge water. Tank bottom survey will be performed before and after the hydrotesting. Hydrotesting will be performed slowly at different levels. 0.25 test height, 0.50. 0.75 then at its full height. Filling the tank with water shall be at least 24 hours after it reaches the full test height. Once the tank is fully hydrotested, tank shall be emptied out of water and left to dry. At this moment, the contractor shall select the type of internal coating. Internal coating shall be applied to the tank bottom and the bottom half of the first shell course. This process will protect the bottom and critical joints from corrosion where water or microbial growth may be present. Thickness of coating shall be at least 30 mils depending on the condition of the steel. External coating may require permit depending on the location of the facility. No tank shall be placed in operation unless it has external coating. Coating will consist of a primer coat, epoxy second coat and a polyurethane as the top coat. Thickness of coating shall be at least 10 mils. Before the tank is placed into full service, all tank piping and appurtenance shall be completed. All manways shall be closed and safety valves are checked and installed. Tank pressure safety valve must be installed and tank top hatches are closed. If tank is connected to the vapor recovery unit, operators must ensure that the valves connecting to the vapor recovery system are open. All cathodic protection and pre-commissioning surveys must be completed. All level alarms must be completely calibrated and tested. Operational procedure for tank fill-up shall be reviewed before placing the tank for continuous operation. If you have any questions, comments, concerns, please leave it in the comments section down below. If you like this video, please like, share, and subscribe. See you in the next video. Thanks for watching.